Hello and welcome to the GCSE Physics tutorial for topic P4 Atomic Structure. This is part 2 looking at radioactive decay. Previously we looked at isotopes. Remember, isotopes want to become stable, and in order to do this they give out radiation. Radiation is often called ionizing radiation, and that means it ionizes atoms by knocking off the electrons in the outer shells. The three types of ionizing radiation we're going to look at are alpha, beta and gamma. First of all, alpha. Sometimes the symbol looks like this. Alpha radiation releases alpha particles. An alpha particle is made of 2 neutrons and 2 protons, shown here. So it actually looks the same as a helium nucleus. Alpha radiation is strongly ionizing and weakly penetrating. When an atom gives out alpha radiation, the atomic number decreases by 2 and the mass number decreases by 4. Here's an example shown below. The helium atom here represents the alpha particle. As you can see, this element, as it's undergone alpha radiation decay, its mass number's gone down by 4 and its atomic number's gone down by 2. Beta radiation releases beta particles. A beta particle is actually a fast-moving electron, so with a charge of negative. For every beta particle emitted, a neutron turns into a proton. Beta radiation is moderately, also medium ionizing and moderately penetrating. When an atom gives out beta radiation, the mass number stays the same, but the atomic number increases by 1, as shown here. This here represents the beta particle, and as you can see, the mass number stays the same, but the atomic number has gone up by 1. Gamma radiation releases gamma rays, so not particles. And gamma rays you will have heard of before. They're transverse waves and they're part of the electromagnetic spectrum, which we'll look at in another topic. Gamma radiation is weakly ionizing out of all three, but strongly penetrating. And gamma rays don't cause no change to the mass or the atomic number. So what do we mean by penetrating? Well, that means how much can it get through materials. So alpha is absorbed by paper, so it is stopped, it couldn't even get through your skin, and it can only travel a few centimetres. Beta is more penetrating. That can be absorbed by a thin sheet of aluminium and can travel a few metres. And gamma is the most penetrating because it can be absorbed by concrete and lead and can travel long distances. So what is a half-life? A half-life is a time taken for the number of radioactive nuclei to halve. So how long it takes for the radioactive substance to halve. And for some substances it could be hundreds of years, and others it could be just a few hours. Radioactive activity is measured in a unit called becquerel. Now, you need to know how to find the half-life, either from a graph or from a question. So from a graph, as shown here, if you had to find the half-life of this substance, you would look at the activity, which it says 80, and halve that. So you'd go to 40, and then you'd go across and then find the time, so 2 days. And then you can do that again, so go for 40 down to 20, and that should go to 4 days. So the half-life is 2 days. If you get a question like this in the exam, make sure you draw on the graph how you found the half-life. If it's from a question, then the best way is to write it out and try and show the half-life like this. So it says a radioactive substance decays from 64 to 16 becquerels in 12 seconds. What's its half-life? Well, if you start at 64, you halve that once, you get to 32. You halve that again, you get to 16. So it's gone through 2 half-lives in 12 seconds, which means it went through 1 half-life in 6 seconds. So the half-life is 6 seconds. It's always best to draw it out to show how the substance is breaking down. If you pause the tutorial now and try these questions. So if a substance has an initial count of 40 becquerels, how much will it have after 3 half-lives? Well, it will have 5. If you just look at how I've done that in the breakdown. What kind of radiation is the most ionizing? Well, that's alpha, and you can tell it's going to be alpha because of the size. It's a particle. And what ionizing means is it basically will have the strongest effect when it hits an atom and knocks off electrons to turn it into an ion. So alpha radiation is probably the most powerful out of the three, the most dangerous, but remember, it can't be absorbed very well. It's not very penetrating. What kind of radiation is the most penetrating? That would be gamma. In summary, we've looked at radioactive decay.